I've put quite a bit of work on the board already, but we'll talk through it. First, I pasted in a picture from the Desmos online graphing calculator, which shows the graph of f of x on the interval from 0 to 1 inclusive. You'd have to probably come up with that picture yourself using techniques of graphing, finding first derivative, concavity, max, mins, etc. But the volume, if we revolve this region about the y-axis, which is this dotted blue line, is probably best achieved by using cylindrical shells. And in that case, the typical shell or rectangle is parallel to the axis of revolution. We call this distance to the center of the shell the average radius. And this is our formula, where the height of the shell, of course, is f of x. So the volume is 2 pi times the definite integral from 0 to 1 of x times f of x dx. And it looks to me like u substitution might work. If I let u equal 1 minus x squared, then du equals negative 2x dx. And also x squared equals 1 minus u from this first equation. And after I have written those down, I think maybe I'll rewrite the way this first definite integral looks. I move this x, let me go to red, out in front of the dx, so that, because this is what I want to end up with, negative 2x dx. So there's the x dx. If I put a negative 2 there, I need to put a negative 1/2 out front. And now I'm ready to apply u substitution. So here's the negative 1/2, 2. When x is 0, that's the original limits of integration from 0 to 1. When x is 0, u is 1. So I put a 1 here. And when x is 1, u is 0. This x squared gets replaced with 1 minus u. The square root of 1 minus x squared gets replaced with u to the 1/2. And negative 2x dx gets replaced with du. And so now we're ready to evaluate this integral. I can interchange the limits of integration from 0 to 1 and make this 1/2 positive, but 1/2 of 2 pi is pi. And so I've got 1 minus u times u to the 1/2 du. I can rewrite this as u to the 1/2 minus u to the 3/2 du. And now the antiderivative is raise the exponent by 1, multiply by the reciprocal of the new exponent, raise the exponent by 1, multiply by the reciprocal of the new exponent, and we're going to evaluate this from 0 to 1. And whatever that number is, we're going to multiply it times pi. So when I put 0 in for u, of course, I'm just going to get 0. So when I put 1 in for u, I get 2/3. U to the 1 to the 2/3 is just 1, minus 2/5. And if you get a common denominator and subtract these fractions and multiply by pi, this is what you get here, 4 pi over 15. And I use the Desmos definite integral function to actually calculate this definite integral, and I get to 0.8377, and I see that 4 pi over 15 has the exact same value, so I'm kind of convinced that this answer is correct. So there you go.